Hello, my name is Rod Elmore, and today we're starting our look at probability. And when we look at probability, today we want to, this one example, I want to point out what a probability experiment is, what well-defined is, the outcome, sample space, and the properties of probability. So we need to take a look at our video homework assignment. And in this case, we're going to look at a crap game. In a crap game, using 2 dice, that's where people have a big table and they take 2 die and they throw them. A person wins on the first roll if they get a 7 or 11. So they're going to take 2 die, they have 6 sides on each one of them. They're going to throw them, so they'll stop, you add the number on the top, and if it comes up to a 7 or 11, when that first roll, then they win. So we want to find out what the probability of winning on the first roll is. So we're in a crap game. And I don't know if you've ever played craps before, but that's all you got to do is throw the dice and hope you get a 7 or 11 to win on the first roll in the simplest of the games. So now let's take a look, and we're going to define these things. So what do we need to do to solve this problem of throwing these 2 dice? Well, we have to know how many outcomes there are. And how can we get the number of outcomes? By taking a look at the sample space. So first we're going to develop a sample space for this problem. And if you think about it, we've got to look at all the possible outcomes. So we're going to make up a nice little simple sample space, and then we can answer all of our questions. Now, is this a probability experiment? Is this a probability experiment? Yes, it is. It's got definite outcomes, well-defined outcomes. They've got to be well-defined and they have to be an outcome. Every time they throw the die, is there any choice? No, unless they balance on the edge or something, then we'd be in trouble. But as long as they stop, we add the 2 numbers, that's our outcome. So the sum of those 2 numbers are our outcome. The sample space we're going to build here, and then we'll look at the properties. So let's see, we've got to have 6 this way. And sample spaces can be built any way you want. This would be a nice little simple one. So this would be 1, 2, 3, 4, 5, 6. So then what would this one be? If one die had 1 up on top and the other one had a 1, we'd have snake eyes, then what's that going to be? It's going to be 2. 1 plus 2 is 3. 1 plus 3 is 4. 1 plus 4 is 5, and so on. And then you can see that 2 plus the 1 is 3. And this is pretty easy to complete then. 3 plus 1 is 4. It's rather one of the easier tables to do. 4 plus 1 is 5. And 5 plus 1 is 6. And 6 plus 1 is 7. So now we'll go back to our crap game. We've got all possible outcomes. You're either going to have a 2, a 3, a 4, a 5, a 6, a 7, or you can go all the way up to 8, 9, 10, 11, 12. So you can have any sum from 2 to 12. You can't get a 1 because the 1 plus 1 is the smallest, and the largest is 6 plus 6. So now let's answer our question. If they throw a 7 or 11, they win on the first throw. So how many outcomes are there? Our definition for probability was the number of successful ways. The probability of event E is the number of successful ways. Number of successful ways over the total number of outcomes. So think about that. Now, how many successful ways are there in our sample space? Well, how many 7s are there? There's a 7, 1, 2, 3, 4, 5, 6 7s. And how many 11s? 2 more, so that's 8 possible outcomes out of our total. So we've got 8. Now, how many total is there? Well, it's 6 by 6, so it's 36 total ways. So the probability of us being successful on the first throw is 8 out of 36, or in this case, that would reduce down to 2 out of 9. So 2 out of 9 ways you're going to win on the first throw. So it'd be pretty bad odds, but there's other things happening in a crap game besides getting 7 and 11. But that would be the situation. So let's kind of look at what we got. We had a probability experiment. We had well-defined outcomes. There they are in our table. Those well-defined outcomes. This is our sample space. Now let's use this example for these properties. Now the properties are this is our first of our properties, and they're listed on that sheet, that the probability has to be between 0 and 1. Between 0 and 1. All of our probabilities for all the potential outcomes going to be between 0 and 1. No matter which one, like what's the probability of getting a 2, for example? Well, the probability of getting a 2, there's only one 2 up here, so it's 2 out of 36. So that is between 0 and 1, isn't it? And let's just list all the other ones. What's the probability of getting a 3? 2 out of 36. What's the probability of getting a 4? 3 out of 36. And what's the probability of getting a 2, 3, 4, 5? We've got 1, 2, 3, 4. 4 out of 36. And then we got a 6. 1, 2, 3, 4, 5 out of 36. And then to get a 7, 6 out of 36. And then the other ones go back down the same way the other ones did. 6, 5. Okay, let me get this down. See, 2 out of 30, wait, I fouled up when I started. 1 out of 36, 2 out of 36, 3 out of 36, 4 out of 36, 5, 6 out of 36, because the 7 is the one mostly that will occur. The 8 starts to go back down to 5, 4, 3, 2, and 1. Let's see, should be pretty 1 through 5, 6, and then backwards 6, 5, 4, 3, 2, 1. And you're going to get one of those numbers, 1 through 12, 2 through 12. You'll get one of those numbers. If you add all these up, what do you get? Well, you get 1, 3, 6, 10, 15, 21, 26, 30, 33, 35, and 36. So if you add them all up, you get 36 over 36. So you will get one of these numbers, and the sum of all of the outcomes will always have to be equal to 1. So all of these are between 0 and 1. The next property is the sum of all the, now this is our sum thing, we're going to add them up, we just did that. We're going to add up all the probabilities like this, and what are the sum always going to add up to? 1. This means sum, 1 to n, and we're going to take all of these choices, and we did that, and they're going to add up to 1. So that's another one of our properties. Another property is, and this is kind of an important one because it's going to be asked to you on a test, if the probability of an event equals 0, what does that mean? And if the probability of an event equals 1, what does that mean? If it turns out to be 0, that means it can't happen. And if it's equals 1, it means it has to happen. It doesn't mean maybe it'll happen. It means it will happen, it will not happen. All the probabilities have to add up to 1, and they'll always have to be between 0 and 1. So if on your calculator you get a probability that's 1.4, it can't be. So you got to check what you did wrong. So this indicates a sample space and the definition of these 4 terms plus these 4 properties. And so that kind of gets you the basis for our probability problems that we'll be doing next. So try these, setting up this problem again on your video homework, and then try the homework problems. Thank you.